welcome to the Mathematicians Podcast, the show where we follow the fascinating stories behind the people that count in the history of mathematics. I'm your host, Benjamin Cornish, and today we're meeting our first John. John Philoponus, or John the Grammarian, or, yes, John of Alexandria, is a Christian theologist, philosopher, and arguably mathematician from Egypt, from around 500 CE. He is primarily known for his religious doctrine, but this is one of those interesting overlaps between maths and religion, the nature of infinity. I used to have a friend who would never stop talking. As school children, we gave him the nickname Chatterbox. He was always a great person to have around, especially if you were adverse to awkward silences. What I liked especially about old Chatterbox was that he was not at all interested in playing games of physical exertion and teamwork. There was one game in particular that my social circle enjoyed, which involved a sphere that one moves with one's feet in an attempt to intercept a line between two jumpers on the floor. This game usually involved difficulties with asthma and the occasional scraped knee. Instead, Chatterbox and I would watch at the sides and discuss the finer points of Kantian ethics. Those summers really did feel like they would go on forever. But the sad reality of being a 7-year-old is that sooner or later one becomes an 8-year-old. And then, before you know it, you're off to different universities, then you get jobs in different European countries and marry entirely different people. And all of a sudden, you go from Kantian ethics to Cartesian solipsism. And I suppose that's the thing about those infinitely long summers. Although at the time they feel like they really will last forever, they don't. And that shouldn't come as a surprise, because when you think about it, the summer cannot last indefinitely. Either it has ended, and thus finite, or it has not ended, and therefore the infinite nature is indeterminate. Still, I yearn for those days where fewer things had been determined. So, John Philoponus. We don't have much information of John's early life. We believe he came from a Christian family, but remember that when we say that, it does not mean the same thing that you might think. He was a Miaphistic, which is a school of Christianity still practiced in Egypt, Ethiopia, Eritrea, and some countries not starting with the letter E, far outside of the Catholic Protestant bubble that I grew up in. I mention this because in the world John inhabited, the orthodoxy of Christianity was still being decided, and it was thinkers like John that helped shape what would eventually become the true faith. Questions like, is God one person or three people? Or two demons wearing a trench coat? Or will the universe carry on going forever? Or does it just feel that way when we debate Christian orthodoxy? But it is this notion of infinity that has made me include John's work in the maths umbrella. So let's consider the state of arguments on infinity from the origins, or perhaps the non-origins of time, to now. You'll hopefully remember a few of these names, and you can go back and hear the full episodes. So Zeno of Alexandria believed that you could continue cutting up time and space into infinitely small chunks, whereas Democritus of Abdera believed you could not. He thought there was a limit of the atoma, or indivisible. Aristotle distinguished between potential infinity in the future and actual infinity in the past, the former an integral part of mathematics and the latter an impossible state that would lead to a paradox. Euclid, in his Elements, proved that there were infinitely many primes, which is an actual infinity that is not time-dependent. They're all here, right now. Eudoxus of Cnidus and Archimedes of Syracuse made use of the method of exhaustion, a process of using actual infinities, or these infinitesimal smallnesses, that somehow add up to be a non-infinite value. In astronomy, we have figures like Ptolemy, who investigated stellar parallax, which no one could find. And that implies that the stellar sphere, the shell on which the stars are painted, are infinitely far away. But then this is impossible, surely. In theology, figures like Constantine of Hippo, so not a mathematician, talked about the timelessness of God, which surely implies a sort of infinity. And this is where the story of John becomes important. The Christians are rapidly becoming the most influential political and military force in the region. But for the religion to be a viable political tool, it has to be consistent. otherwise it would be rejected by the educated pagan population of philosopher-civic leaders. So if you throw around an accusation like God is beyond time, you need to be able to justify all the implications. You would also need to distinguish your own religion from that of pre-existing pagan pantheons. So if the pagans believe something, it must be wrong, and that means that the contrary view needs to be expounded on. Well, let's hire a mathematician to figure it out. One big frontier of the quasi-scientific theological war of the time was the prevailing Aristotelian view that the world had always existed, an infinite and stable cosmos. One aspect of this is that there is no creator, which does not gel with the Christians. John says that this is nonsense. He makes the argument that if today is day number n, yesterday was n minus 1, and this can be carried on indefinitely, but that means you'd be able to count to infinity backwards, making it akin to a potential infinity that cannot ever be reached. But given that we have reached the present day, when the argument is reversed, it's suggesting that after counting a potential infinity, we arrive at the present day, an actual infinity, and this is a paradox. The solution to this is that the world was created, brackets, by the God that I believe in, end brackets, a finite time ago. He also mocks the view by suggesting that if the past was infinite today, what will it be tomorrow? More infinite? Can infinity increase? Are there infinities of different sizes? Well, these are some interesting questions, not ones that I can answer, but through this argument we can infer that he has an implicit acceptance of potential infinity that is uncompleted. We also see the arguments of infinity applied through the conservation of momentum, that is, the heavenly bodies. Had they been orbiting for an infinity, that would suggest an infinite power. And this contradicts the idea that everything could be measurable in actual numbers, rather than actual infinities. You might also notice that this argument suggests a nuanced view of how motion worked in ancient times, and we've not yet had Newton's first law, that objects in motion stay in motion, yada yada yada. The ancients had never worked in this closed system with no resistive forces. So infinite motion to them would have implied that there is also infinite power to overcome the infinite resistance. For John Philoponus, the world was created, given a finite amount of energy, and will eventually slow down to a halt. And this is a great analogue of today's prevailing theory, that the Big Bang started, then there's this little bit of mess in the middle, and then we reach the eventual heat death of the universe. Finite. This is another of John's mathematical gifts, something he called the initial impetus. An object is given an impetus, and then it will begin to move until its impetus has been exhausted. So it's close to the formal idea of impulse and momentum and drag. Keeping with the themes of mathematical physics, John had a word to say on the nature of a vacuum. By this time, we are already well aware of the nature of negative pressure, by which we mean a pressure that is less than the air around it. Philo of Byzantium has been playing with siphons and vacuums for nearly 1,000 years. But Aristotle argued that everything moves through a medium, and the notion of a vacuum, that is, empty void, is impossible, as that would imply an infinite speed. And I think we're all happy to deny an infinite speed. So John argued that the medium is not necessary to maintain motion, that the inertia comes from within and is related to its weight and impetus. Moreover, the medium impedes the motion proportional to its density. So he noticed that an arrow can fly meters through the air, but then only inches through wood, and not at all through stone. And this is a great indication of the idea of fluid drag forces. So as the air flows around the arrow, this then allows for a vacuum, and in fact makes the vacuum necessary, as everything else has to get out of the way of the moving object. But a perfect vacuum would also imply perfect conditions for whatever motion was predicted by the impetus. So this is a huge step change in the mindset of mechanical motion. And I should point out that this is one of those insights that only moved east and was ignored west for about 1,000 years. Back to the religious overlap then, let's consider the difference between the Aristotelian and Philoponesian model. In Aristotle's model, all motion requires a constant force. If no force acts, then an object will be stationary. In the realm of the everyday, there is some curious workings going on with air currents, or more traditionally horses pulling, but this is well known that if a man stands on a frozen lake and tries to push a log, then both the man and the log will be moved apart. Every movement will cause an additional movement on the mover, and this will not do for the heavenly bodies, as they sit within the void, so there is no mover. Here, Aristotle introduces the idea of the unmoved mover, or prime mover, which sits outside of his model and can move without being moved. In contrast, John argues that motion does not require constant force, and is the product of an initial movement, suggesting a created cause. And this maps nicely onto the differing schools of religion. Theism, which is the one that is most prevalent in the organised religion, suggests that God created the universe and interacts with it. Pantheism, like various pagan affiliates, would suggest that God is the universe, or pantheism would suggest that God is in everything in the universe. Both of these could be loosely described as God as the non-creator role, only an interactive role. Whereas deism, more of a philosophical position, believes that there is, or perhaps was, a God who created and then leaves it alone. Maybe it matters if you pray, maybe it doesn't. I find it interesting that the most dominant belief system now is the one that consists of people who believe that they need to act in a certain way to get bonus points in life for convincing other people to act the same way. Rather than the one that tells everyone that it doesn't matter how they act because God is either everywhere or nowhere. The second position is more seductive, but has no incentive to forcibly convert other people at the end of a spear. Who knew that discussing astronomy and kinematics would have such an interesting relationship to religious conflict? Well, these guys did, at this stage in history. Yes, people were mathematicians, scientists and philosophers, but almost universally in service to their theological preferences. So, apart from writing a commentary on pretty much everything Aristotle said, and then writing a refutation, so the ancient version of a diss track, on much of what Aristotle said, what else did John give to maths? Let's rotate our attention towards the astrolabe. Not invented by John, but more of a cumulative effort of stereographic projection by Hipparchus, conics by Apollonius, and star maps by Ptolemy, the first suspected real-life physical device is thought to have been invented by either John of Alexandria or, and I simply cannot believe I didn't find this the other week when I was writing, his daughter Hypatia. I think because I've been talking about precursors to the astrolabe for so long, I didn't notice the significance that Hypatia actually had. She had one and taught people how to use it, and that is huge. But I'm sure I have a very forgiving audience. I missed out on the Hypatia week. We'll put it in now. She was amazing. However, we have to wait for John to give definitive proof that the astrolabe was in circulation, because he actually wrote the book on how to use it, a book that is still extant, and a book that I shall quote from for no other reason than I find reading ancient text incredibly wholesome. By the way, this is from the first chapter describing the design of the thing. The two straight lines on the plane surface on which the rule lies, cutting one another in the middle, correspond to the meridian line and the horizon. Of these, the one descending from above, from the ring whereby we suspend the instrument, corresponds to the meridian line in each zone, the other cutting it in two at right angles corresponding to the horizon. On this latter, the one corresponding to the horizon stands in a semicircle having this line itself in its diameter. This semicircle corresponds to the hemisphere of the heaven above the earth, and this semicircle is cut in two by the other line. That descending from the ring, which we said corresponds to the meridian line, the cutting taking place by the upper end of the line near the ring. Each of the quadrants on either side has been divided into 90 degrees, on which the index of the rule falls, and thereby we determine the meridian height above the horizon of the sun, or any other star, how many degrees each hour it has been raised above the rising's or the setting's horizon. The 90th degree indicates the sign at the summit in the case of each house, and the first degree what is next to the horizon itself, whether the rising or the setting one, as the using of the instrument will teach us as we proceed. It is not the case, however, that in all astrolabes both quadrants have been divided into the 90 degrees, but only one of them. For one, whichever it happens to be, is enough for our observing, for it is possible to know by either quadrant how far the sun, or any other star, has been raised from the setting or from the rising horizon. But that we may find it easy to observe, when the instrument is suspended with either hand, in some cases both the quadrants have been engraved. Oh, that was translated by Herbert Wilson Green in 1933, and you can find the full source on the internet. Just search for John Philoponus on the Astrolabe. So you can use the thing to answer three main questions. Where are you? Where are you going? And what time is it? It's basically a star map that you dangle, line up with the target star, and then rotate part of it to find the angle of elevation of one thing or another. And then this will help you work out where you are or what the time is. It was incredibly versatile and was used for centuries by astronomers, navigators, astrologers, and even priests for practical tasks and less practical tasks like astrology. And it was one of the most important scientific instruments before the invention of more advanced tools like the telescope. So, John Philoponus described the most influential scientific instrument of the age, gave a big push to the concept of momentum, and had an almost unlimited number of things to say about the concept of infinity. Cheers, John. Now, I know what you're thinking. It's not entirely fair to let this monk slam down on 1,000 years of Aristotelian mechanics and cosmology without a defence. So, to whom shall we give the right to reply? Luckily, that is for our next mathematician, Simplicius, to give the other side of the story and provide some coherence to the pagan cosmological view. But between any big arguments between two mathematicians on the concept of infinity, it is a good idea to take a breather. So next week we will be speaking to a very modern mathematician. Given that our story is taking a big focus on the nature of infinity, I felt it would be a good idea to ask an expert on infinity, or perhaps I should say infinities. So next week we will be doing another special episode of the Injectives, and I'm sure you will potentially find it actually interesting, or is it that you'll find it actually potentially interesting, as I ask Hope Duncan the limit as n tends to infinity of n questions. Before then, don't forget to say hello to me on Blue Sky at mathematicians-pod. Perhaps you could suggest a question I ask to Hope, although you'll have to get in there quick because the recording of that interview is taking place the day before this one airs. Until then, goodbye! The music today is Dance Macabre Finale by Kevin MacLeod. You can find more information in the show notes.